think it is recording. Okay, so this course is introduction, this unit to data science and data analytics. So there has been a confusion between the two, that's data science and data analytics. That's why you need to understand what's data analytics, what's data science, how how are they related? How can we use data science and data analytics? I, I don't know if you know the difference. Okay, that there's a confusion all over, and it is very clear if we get it right. So when we are talking about data analytics, we are talking about the process of analyzing raw data. Raw data, for instance, I will now be using example on where you are. You are maybe, as you are saying that you are working on supply chain and so on. You see, you might be having data on maybe how many, I don't know how the oil and gas are measured, the units and so on. Maybe in terms of demand in January, the demand in Nairobi was this unit in February and so on. That data that you have in the system is raw data. Raw why? Yes, you have, but it has been not been analyzed for decision making. Like you cannot make a decision in it. So it is called raw data. So the process now of analyzing this raw data so that you are able to pull some insights. Like now, maybe you see, you find out that maybe what was the average um, amount of maybe gas that was delivered in terms of cubic, I think it's cubic meter, something like that. I don't know how it is measured, and so on. So that process now is called data analytics because you are able to pull the insights which are useful to the company. So the importance of those now insights are to drive what called smart decisions. Like you are able to use it to make decisions because you are saying that if you have data in the organization, there is no need of you like having guesswork and so on. So I'll share the entire notes and so on, but maybe in case you have points, you can just be taking. So data analytics is a kind of business intelligence that is used to solve problems and challenges that every company is facing. So I think I have introduced another new concept, business intelligence. Business intelligence is part of data analytics and data science, whereby you look at the historically available data in the company and try to explain what happened. So you are trying to see what happened in the past, but not today and in the future. That's business uh, intelligence, which is part of data analytics. Now, having seen the definition of data analytics, as we say that we are using raw data, you are trying to make insights out of raw data. We now look at now, having known the definition, uh, what are the steps in your organization if you have data? What are the steps that you need to have? The first one is that, first of all, before you do any analysis, you need to define a question. What do you want out of the data? So you have to define the question you need to answer. Like, why are you conducting the analysis? When now you know that, you will know now the type of data that you will need. In an organization, we have a lot of data from the HR department, from finance, across multiple departments. You might not need all that data, but you might need the specific kind of data in the organization. So now after you ask the question and identify the type of data that you need, now you will proceed to what you call data collection. Data collection does not mean that you have to go to the field to administer questionnaires and so on. Data collection means that you look at, is that data available? If it is available in the organization, where is it stored? Is it stored in the internal databases? Or do I need to go, if it is not available, do I need to go to the field to administer questionnaires or to the internet to mine data that are available, because nowadays we have a lot of information. So that is what I mean by data collection. It doesn't mean that you go to the field. You look at, is this data available in the organization? Then after that, we have now what we call data cleaning. You see, when you are having data which is in raw format, it doesn't mean that it is ready for use or consumption. So we have what called data cleaning. This part is called data pre-processing. So you are trying to prepare your data for further analysis. Then after you clean now your data, in fact most of the work of our data scientists and analysts is there. This step on data cleaning. After that now, you do what called analysis, whereby you analyze your data. Of course, after analyzing your data now, you do what called data interpretation and share the results. Like, to interpret is based now on your research. Why has the performance dropped? What are the factors affecting? Are they external, internal, and so on? So those are the crucial steps in data analytics. First of all, you need to know what you want, where to get the data from. Once you get the data, you clean, you analyze, then you interpret. So having defined data analytics as the process of transforming raw data to make insights, now it is good when we look at what we call data science now, because there is a distinction between the two. So we are saying that when you are talking about data science, we are saying that data science is a term that escapes any single complete definition. Like, there is no universal definition of data science. Like, for instance, in medicine, when COVID came, they gave a name as COVID-19, which became universal. Wherever you go, when you're talking about COVID-19, people know what it means. So, therefore, we are saying we have seen many articles and publications use the phrase freely with the assumption that it is universally understood, which is not the case. So, however, when we are talking about data science, we are talking about methods, goals, and applications that evolve with time and technology. So, meaning that data science, as you see, the second last point, it is saying that data science 25 years ago, so data science has been there. It is not a new concept here. So data science 25 years ago referred to gathering and cleaning data set, then applying statistical methods to that data. Especially those people who did economics and statistics that time, it was still data science. But the kind of technology, how it was approached that time, has evolved over time. That's why in 2018 onwards now, even in Kenya, that's the time when now the issue of data science became so much rampant and so on. So in 2018 onwards, data science has grown to a field that is made up of data analysis, which we have defined, predictive analytics. Predictive analytics, we are trying now to forecast the future. Maybe how, in terms of how much maybe liters of petrol do we require in the next 2 years. So that is predictive analytics. Then data mining. Data mining, you are trying to look at information maybe over the internet and so on that is not readily available. Business intelligence. Business intelligence, as I have said, is that you have historical data in the organization, you try to answer what happened. That's business intelligence. Then machine learning. In machine learning, this is whereby you have what called algorithm. Algorithm is like a formula that does a specific task without so much human intervention. Like for instance, if you have a calculator and you give even a toddler that is able to put like to maybe to do a summation of 1 plus 1, they'll get 2. Even yourself, you know that 1 plus 1, it will be equal to 2. But you don't know behind the scenes what is happening to give you the 2. So that is what you call machine learning. Then deep learning is part of machine learning, like an advanced machine learning. So deep learning, one example that I gave was the issue of image detection used by banks for verification and so on. Another one, for instance, maybe you are talking about the energy sector and so on. You can use what's called computer vision, which is part of machine learning, maybe to be able to monitor the sites where the maybe oil pipelines and so on pass, and so some kind of maybe if you have vandalism and so on. So it is part of deep learning. So in summary, we are saying that data science is a very large scope because it is made up of very many disciplines. And at the end of this course, you'll be able to manage all these disciplines of data science. So, having looked at that definition now of data science and machine learning, data science and data analytics, it is very now important to understand what's the core difference between the two. So, to look at the difference between data science and data analytics, we have to look at the difference between data analytics and data science. I have here the focus area. Focus area, I have looked at 3 critical ones. First of all, the objective and focus of each one of them. Another one, we have the methods and approaches. Then we have the skill set and expertise that is required by both of them. So, in terms of objective and focus, data science aims to uncover hidden patterns, relationships, and trends to solve intricate problems and make predictions or recommendations based on data-driven insights. In summary of all this story is that data science is more exploratory. I'm going to give an example of what it means. But when we go to data analytics, we are saying that data analytics focuses on understanding past and present data patterns to optimize business operations, enhance efficiency, and gain competitive edge. So data analytics is more focused on immediate decision making. Like if you want to know maybe like the amount of the volume of gas that has been supplied maybe in the past 6 months, maybe the mean and so on. That one you can get it immediately, right? Maybe if it has gone up and down based on the available data. That's data analytics. Now, if you find that the volume has gone up or down, you need to explain why. So data analytics cannot assist you in that. Now, that's where data science comes in. It tries to answer the question why. But data analytics answers what has happened and so on. So, in summary, when you look at the objective and focus of the two, data science is more exploratory, while data analytics is more focused on immediate decision making. Looking looking at the methods and approaches now, data science involves a holistic process that includes data acquisition, like to acquire data is that part of collection, cleaning of this data, like preparing it for further analysis, exploration, trying to see how your data is distributed and so on, transformation, modeling, and evaluation. So in short, data science deals with complex and structured data and utilizes sophisticated algorithms. An algorithm is like just a formula, such as neural networks and deep learning. So it looks further. You see, unstructured data is like images, voice notes, text, and so on. So you see, all that data can be used to make decisions. So that's where data science comes in. When we go now to data analytics follows a streamlined process focusing on descriptive and diagnostic analysis. It involves data cleaning, visualization, and statistical analysis and data mining techniques. And in terms of tools that are mostly used for data analytics, one is Microsoft Excel. We have what's called SQL, Structured Query Language, and I have explained in the curriculum what we need it for querying data. Then we have data visualization, just to try to present your data in tables and so on. And this one mostly is the software used at Power BI or Then now, what are the skill set and expertise of these two different kind of people? Data science, they work mostly with Python. You saw in the curriculum we have Python there, or algorithms, and big data framework such as Hadoop and so on. You learn all of them practically. While data analysts focus more on data manipulation, visualization, and storytelling. So they are proficient in SQL, data querying, manipulation, and visualization tools like Tableau or Power BI. So this is the difference between the two. However, in this curriculum, you will be an all-rounded. You will still be a data scientist and a data analyst, and we are going to see that. Okay, I have gone. So let us not focus more on the data engineer part, ignore this part. Let us focus on Liz and Tom. So, but we have this company called Wonder Waters, and what it does, it has water filtration, there is water products and water distribution. We want to distinguish between a data analyst and data scientist in the same organization, right? So, Liz, who is a data analyst, does water analysis quality. She looks at maybe pH value, pH, I think it focuses on maybe acidity and acidity of the water, if I'm not wrong. So he does water analysis quality by looking at pH levels and so on. Then he recommends new water products based on that, identifies current demand of water products based on data, and enable business to build market strategy. While Tom builds a statistical model to predict potential health benefits of consuming waters, packaged drinking water, and so on. So this one now tries to look at the hidden behavior and so on found in this. But one thing is clear: if you look at what Tom does critically, you will still end using this information to be able to proceed with the analysis. But Liz cannot use Tom's information to do the analysis, meaning that you can not, you can be a data scientist, you can, like, in short, what it means, the roadmap to a data scientist is data analytics. So this one means. So going forward, now we have seen there's a distinction between the two. Now we want now to bridge the gap. What's the collaboration between data science and analytics team in an organization? So you have seen that data science and analytics have distinct characteristics. They are not mutually exclusive. Like there's no that so big difference between the two. So they complement each other in providing comprehensive and holistic approach that is to data-driven problem solving and so on. So mostly data analytics forms the foundation for data science, and meaning that it provides insights that guide the process of data exploration, modeling, and prediction. Because we say that data science is more exploratory. Therefore, data analytics creates the roadmap towards that. So, data science leverages advanced algorithms to build predictive and prescriptive models using the insights generated by data analytics team. So, you have seen that yes, there is a distinction between the two, but they must work together and so on. Maybe before I proceed further, is there anything that is not clear? Okay. So, I think now we can look at what called data. We can look at data. I don't know why this has started misbehaving. Okay, we can now look at what we call data. So, I want us to look at data based on two aspects. One, the traditional data and the modern data, which we call big data. So, as we have said that data is the foundation of data science, so it is the material in which all the analysis are based. In the context of data science, there are two types of data. We have the traditional data and what we call big data. So, traditional data is data that is structured and stored in databases, which can be managed from one computer, and it is in table format containing numeric and text values. Let me demonstrate here. So, when we are talking about traditional data, we are not talking about traditional data based on age, like the age. You see, sometimes when we say traditional, we think that it is based on maybe age. We are talking about traditional based on the structure. So, traditional data, we have said that the data is structured and stored in databases which can be managed from one computer. It is in table format containing numeric or text values. So, This is what we mean. So, a table, maybe let us say we have a name, maybe ID number, phone number, and so on. So we have maybe a name here, maybe ID number, something like that, maybe phone number 0100. Then I have a name here, maybe something like that, 01. So you see this data is in a table format and is structured. So the first column has the name, right? The second column, name is in form of text. This is text. Then ID number is form of, it is numeric of numbers. Then phone number is as well numeric. So this is what we mean by traditional data. So based on this data, you see, the main reason I was saying that let us not define traditional data based on age, but I don't know. Yes? Yeah, it is representation of how it is. That's why we mean by traditional data. So mostly, this traditional data is stored in relational databases. They are called relational databases. Such as SQL, structured query language, and so on. So this is what we mean by traditional data. Now, the next one is called big data. It's what's called big data. From the name big, this is extremely large data, and this data is distributed across a network of computers, but it is not just characterized by its volume. This data can be in various formats. It can be structured, semi-structured, or unstructured. Structured is that one. Unstructured is like images, text. Text is semi-structured, but images, voice notes. What else do people post on social media? Images, voice notes, text, of course, even numbers. So unstructured mostly, so semi-structured, we find text, and so on. So big data, it has three main characteristics. One is variety. Variety, as we have said, it is in form of numbers, text, images, audio, and so on. So that means variety, like in various formats. So when we are talking about velocity, we are talking about speed. It is retrieved and computed in real time. Let me give an example. If maybe I'm your friend in social media, maybe LinkedIn or Facebook or wherever, if you post something right now, the moment you send it, I'll be able to see. So you see, it is being retrieved and computed in real time. Then another one is volume. Like it is voluminous, it is big. Because another simple example, as we are speaking, how many people are posting on social media? A lot. So a lot of data is being generated within minutes, seconds, and so on. So you can see all that data is very voluminous and so on. And big data is not stored in relational databases. So big data is stored in what's called data lakes. Big data is stored in data lakes. It's called data lakes. So, yes? Okay. So, big data, you see, many organizations are struggling to find experts to analyze big data. That's why you need machine learning engineers and so on. And machine learning engineers, of course, are data scientists. They are data scientists specializing in machine learning alone. So, that is, with this organization, need data scientists or machine learning engineers to be able to track on this type of data, especially the semi-structured and unstructured. The data analysts cannot deal with this. They are limited because even as we saw the tools, the data analysts are working mostly with SQL, Tableau, and Power BI, and Excel. Yeah, Excel cannot analyze an image. Yeah. So having looked at that, the next question is, what do you do to data? What do you do to data? What do you do to data? That's the next question. So given that in this class, the next person will join maybe later, this one is you who is going to answer it. Yeah. So before the answer, consider this. So you are going to give yourself a minute to learn the difference between the two scenarios. So imagine the following scenario. You are an analyst for a large company and your manager approaches you with the following request. The first one, we need to consider client satisfaction in the quarter so we can predict churn rate. Churn rate, I have said, is that rate at which people stop to use a certain product. So you have been told to oversee the process and come up with some numbers. The next one, we have an enormous amount of customer data from the previous quarter. Can you oversee the analysis and deliver an approximation of churn rates for the next quarter? Like, we have an enormous amount of data. Can you oversee the analysis and deliver an approximation of churn rates for the next quarter? The first one, they were saying, we need to consider client satisfaction in the quarter so we can predict churn rate, oversee the process and come up with some numbers. Oversee the process and come up with some numbers. But this they are saying, we have an enormous amount of customer data from the previous quarter. Can you oversee the analysis and deliver an approximation of churn rates for the next quarter? So what's the difference between the two? What have you seen between the two scenarios? Just look at it clearly, it's very clear. Don't even think. Just read the statements very well and you'll be able to see. Yes? No, just a trial. Maybe to guide you further. In the first statement, there's something missing. No, and like based on the statement, the way this person is saying, in the first one there's something missing. In the second one there's something available. Yes. Yeah. So maybe you can use that now to tell me the difference between the Okay, no worries. So it is. You see, in the first statement, there is no available data in the company. Yes. You have been just told to do the analysis. You have not been told if we have the data or not. Yes. This one already there is customer data. Yeah. So this is what you are trying to look into. So now, no data, raw data, of course, but now that one leads us to whatever I mentioned on the processing of data. So, uh, we are saying that regardless of whether a data scientist is given just collected data, you see, that person was told that there was data. So, if they were given just collected data, or they have to go through the gathering process themselves, this data is going to be in raw format. So this data can come from surveys or through automatic data collection, perhaps such as cookies. Cookies in the website sometimes nowadays, when you visit a site, you are being told to accept cookies. Yeah. When you accept, they start collecting your data. So that is what you mean by that. So raw data is untagged data that needs to be converted into a form that is more understandable and useful for further processing. Raw data is untagged data that needs to be converted into a form that is more understandable and useful for further processing. So, the group of operations that do this are called data pre-processing. Like, so data cleaning is part of pre-processing. Pre-processing is the large scope. So we are going to see some of the now data pre-processing methods, which data cleaning is part of it. Yeah. So, but what is clear here from this area is that even in the organizations, irrespective of how much organized the data is, like this one that I have tried to get here, this data will never be clean. It needs to be pre-processed because not everyone in an organization is an expert, even in Excel. So maybe you need to assist them to remove even the name column, and maybe they are interested in two only, the ID number and phone number. Yeah, so that is data pre-processing. So let us now look at common data pre-processing methods. One is what we call class labeling the observations. Class labeling. So this consists of arranging data by category, or you label the data points to the correct data types. Like for instance, this one, you see, traditional data, as we have said, that can be numerical or categorical. So for instance, you label that if this column, ID number and phone numbers are, these are numerical, then our names, maybe if you add gender here, gender, maybe you can say Senteu F, mean female, Xavier M. So this is categorical. Categorical is even when we talk about names of countries and so on, we are talking about data that cannot take more than one form. Like Kenya, there's no data, so Kenya can become Uganda and Uganda can become Kenya. That is categorical kind of data and so on. So class labeling is one way of data pre-processing. The next one is data cleansing or data cleaning or data scrubbing, the one now we are talking about. So this one mostly is dealing with inconsistent data such as misspelled categories, if there's a misspelling, and missing values. You see, you can have data that has missing values. When before analysis, you will learn later how to deal with it. Maybe, let us say, we are talking about age of students, right, in a class. If we have missing values and so on, what can happen sometimes, we can calculate the mean of the available and replace, where they have a missing to replace with the mean and so on. But it depends, because if the missing values are too many and you use a mean, it, yeah, too low, and also it can give you wrong assumption. So we have various methods that you look at on how to deal with these values, because before you proceed with the analysis, you have to address that one first. So another one is called data balancing. If the categories in the data contain an equal number of observations, they may not be representative of the population. And this one you will learn in what you call future engineering in machine learning. This one happens, I was giving that example when we started, like if you have a situation whereby you want to make a prediction and one item or variable is so much higher than the other, it is called an imbalanced data set. When you have an imbalanced data set, you have to do what you call data balancing, such as we have normalization and what called standardization. Standardization mostly, you see, for instance, when national exams are marked, they standardize the results to follow what you call a normal distribution. Like many students make that score in C, we have few A's, few B plus, something like that. So you are trying to balance to ensure that no one is disadvantaged. That's how they do normal. They try to standardize the results. They don't release the way they are. So that's why you can find some, or maybe in a specific subject, you score maybe an A, is supposed to start at 80, but still, because maybe the exam was so difficult and no one scored this, an A can even start at 50%. So that is something like balancing. Then another data processing method is called data shuffling. So you try just to rearrange your data points to eliminate unwanted patterns and improve predictive performance further on. For example, if the first 100 observations in the data are from the first 100 people who have used a website, the data is not randomized and patterns due to sampling emerge. So what does it mean? For instance, if you want to collect, like you want to conduct a survey in your company, right? You need to do what called sampling. Sampling means that maybe let us say this class carries like 16 students, and I want us to do some sampling. So it should not be the case that when I'm distributing in my sample, all those students who are seated here are the ones to be selected. It should be random. One here, there, and so on. So that data shuffling, mostly, it means that randomization. You are trying to ensure that like a specific point of the population that are not the ones to be advantaged only, but it should be randomized, like the chance should fall to anyone, not specific people. That's what you mean by shuffling. Then we have this is very critical. I don't know if you have ever heard on the current debate on data privacy and governance. Data privacy and governance. What about have you heard the Office of Data, ODB? It's called Office of Data Privacy and something. Okay, no, I guess. So this one is a very serious issue. Nowadays, the issues of data privacy and so on. So, data masking. Yeah, no worries. Did you have something? No. Okay. Data masking of big data aims to ensure that any confidential information in the data remains private without hindering the analysis and extraction of insights. So, masking now involves you try to hide the original data with random and false data, allowing the scientists to conduct the analysis without compromising on private details. Like instance here, I have our names. Maybe suppose we have ID numbers. Our ID numbers are private. Phone numbers are also private. Maybe I have age, column, and gender. So if I want to do my analysis, even if I'm going to maintain my age and gender, I don't know why this is misbehaving, but it can be a signal issue. So I might be required to restart my machine. Mostly it is a signal issue. Okay, so let me explain that further. So if I'm going to remove our names and maybe ID numbers and phone numbers, you won't know, and I'm just interested to calculate the mean age of the students and so on. That one is not going to compromise on the analysis. So that is what you call data masking. So maybe having looked at that, do you have any question? You don't have a question? Everything is clear. Just a minute. Someone needs keys to access here. Yeah, so that one leads us somewhere. We have what called data quality assessment. So, what's the time? I give, we will go for a 1 hour break at 12 to 1, then we come back 1 to 2, then we finish. Yeah. So, we have what called data quality assessment. So we have seen that, yes, in an organization, it is very important to do what called data pre-processing, right? But as a company, we can put interventions to ensure that we don't have so much work to be done in data pre-processing. That leads us to what called data quality assessment. Like the question is, does your data measure up? Like wherever in your company that you are working and so on, we have some kind of critical questions that need to be asked and answered. So, many companies have been struggling with the issue of poor data quality for a long time. And it is not just about the cost of the areas, but also the lost opportunities that can come from inaccurate information. Because if you have information that is not reliable, then that is a problem. So, measuring data quality involves, in an organization, performing what is called data quality assessment to determine the degree to which your data adequately supports the business needs of the company. So, it is not about having data, but the data, the quality of the data, is it irrelevant to your business needs? Because if you continue storing irrelevant data and so on, you see this data also is stored in databases, and databases means storage, it means infrastructure and so on. So you don't just store data, but you store data that is relevant. Yeah. So So a data quality assessment, we normally call it DQA, is that process now that you can use to assess the quality of the data set. So the data quality, it helps the organization in identifying where there are gaps in the data, which can be filled by the data provider. So a data provider here, it can be internally or externally. Like in an organization, we have maybe IT departments who manage the database and so on. So if we have gaps they need to address, that's internally. Externally, maybe you have been given data to do an analysis and it has gaps. Whoever gave you that data is the data provider. So therefore, data quality assessment can help organizations to improve their data quality and avoid costly mistakes, because if you don't have good data, it can really be costly to organizations. So as a company, there's need to understand the strengths and weaknesses of your data. So if you understand the weaknesses and strengths of your data, it will assist you to improve on the quality and so on. Even as an individual and so on, if you understand your strengths and weaknesses, it is easy to interact with people and so on. Therefore, a data quality assessment is done by measuring particular features of the data to see if they meet the defined standards. That's the purpose of data quality. So it is very important, whatever we learn from this slide is that for any organization, it is very crucial to have data quality interventions to ensure that you have relevant data, and if you put interventions, it assists you to minimize on the cost or errors that can be attributed to having poor data. But now the question is, how can I do my data quality assessment as an organization? So we are going to look at this then. I have an example somewhere, then I think we can go for that break. So when in an organization, when you get even your data, you have to look at, we have some metrics that will assist you or guide you to perform a data quality assessment. The first one, you look at completeness. Is your data complete? So when we are talking about completeness, it relates to whether all required information is present in the data set. All required. So for example, if the customer information in a database is required, maybe to include both first name and last name, then any record in which the first name or the last name field is not populated is marked as incomplete, because that was the requirement and it was not there. So the metric that is used now, what's the metrics, the measure, is assessing this dimension is the percentage of records that are complete. So you look at, out of the data set that you sent to me, in this column, maybe 50% only one complete. The next one is validity. Is your data valid? That is, for instance, when we are talking about validity, we are talking about like the specific, like if for instance it matches the rules specified for it, like you have some rules that you need to put with regards to the data, like is the data, is it in line with the rules that have been set? For instance, I have an example here. If the rules specifically include specifications such as the format, maybe your data, you are looking at the number of digits, you have specified these rules that in my data set, in my ID number, for mostly our ID numbers in Kenya is between 7 and 8 digits. If it goes beyond that, then the validity, like it becomes invalid. So for instance, if also we are talking that my data should have just integer strings and so on, maybe minimum and maximum values, and it doesn't have a specified, then it becomes invalid. And also there's an example here that I have given, maybe for a telephone number field that contains the string, like you see this one, it has some quotation marks, like 1809 arc string, it's not valid because the metric for this dimension, you are looking at the number of records in which all values are valid. And maybe, as I have said, that validity, you have to set rules. So you set rules that maybe in the data in organization we need to A, B, C, D. If it doesn't meet that, then it becomes invalid, that specific row or column, and it needs to be amended. Another one is called timeless. So this one, it relates to whether the information is up to date. So suppose during your admission process at AfriCDSA, you provided a certain email number, then later you communicated to us and said that you need to change. After the communication, maybe the operations team does not update. Then when we require this information, we find out that it is not updated. That data violates the validity metric. So it is not valid because it is not, so not validity, the timeliness, metrics and so on. So, for instance now, the metric used to measure timeliness is the time difference between when data is needed and when it is available. So there's another example here, like for instance, as we have said that it looks if the information is up to date, and also otherwise is the correct information available when needed. So, for example, if a customer has notified the company of an address change, but the new address is not in the database at the time of billing, when billing statements are processed, then that entry fails the timeless test. And therefore, the metric used to measure is the difference between when data is needed and when it is available. Another one is consistency. So a data item is consistent of all representation of that item across data stores match, like across various data stores. And this is something I saw when I was working in my last organization as a data scientist. For instance, if a birth date is entered into one system using the US format, but it is imported into another system where the date is using the European standard, then that data lacks consistency. Because, and I found out that one, like in my last organization, I used to download, there was an administration portal, so I used to download my data before analysis. So when I download, first of all, it comes as an Excel document. So in that Excel document now, I was using Python to analyze. I used to upload to analyze. It was bringing errors on the dates and so on. So what used to happen, the way the data set was in the portal, the date format, when you download to Excel, it used to change. So I used again to clean it, to change in that original format before further analysis. So the data was not consistent. Another one is accuracy. Accuracy here simply means that is your information captured well, the way it is supposed to. Like if you have been paying your fees in installment, maybe 15,000 Kenyan shillings monthly, and it is captured as 10,000, you see it is inaccurate, like the information has not been captured the way it should be. So those are the crucial metrics that you need to know when assessing data quality. Maybe I want to show you something before we go for a break. There's something. So I want to show you this. So this one is a report, data analytics approach. It is just a sample, not actual, by a business intelligence analyst at AFRY-CDSA for this company. So basically, the agenda was to look at introduction. Of course, it was a report, data exploration, model development, and interpretation. Sorry. So, first of all, this company, it has addressed problem, the content to be analyzed. So they give you, of course, what they expect and so on. So, this company is a medium-sized bikes and cycling accessories company and is working on how they can optimize their sales. The company has provided you with three data sets. One is customer demographics. The second data set is customer addresses, and the third is transactional data in the past 3 months for analysis. The main objective is to draw useful customer insights which will help them optimize resource allocation for targeted marketing from the analysis. So the purpose of all this analysis is for targeted marketing, or to be used by the marketing department. So the content to be analyzed, also they give you the past 3 years bike-related purchases by gender. Another one is old and new customer jobs industry category distribution, old and new customer and distribution, wealth segment by age for all the new customers, and number of cars owned and not owned in each state. So, the first thing, when you have been given this assessment of data quality and completeness in preparation for analysis, you should put your report in such kind of a table. So we have the matrix here. This one, the values, I think I entered wrong. There's no matrix like that. But we have the matrix column. The first one is the matrix. Then, remember you are given how many data sets? 3. So, in each data set you do, first of all, we start with the accuracy. So, in that data set, for instance, the customer demographic, in terms of accuracy, the age column was not included. So, you specify that in the data set that the customer demographic data that you gave to me, there was no age column. On the customer addresses data, it is blank, it means it was complete. So we are supposed to, complete. In the transactional data, the profits column was not calculated and it was supposed to be there. So it was not accurate. In terms of completeness, In customer demographic, the last name column had blank cells, so it means it is not complete. Then the job title column has blank cells and the customer ID was not complete. In the customer addresses, the customer ID was not complete. And on the transactional data, the online order column had blank cells. The brand columns had blank cells and the customer ID was not complete. Then you look at the consistency, the area and the gender was inconsistent, the steps were consistent, and so on. So basically, the purpose of this, why I'm showing you this, is for you to know how to structure. Like you come up with something like this, you look at metrics, then depending with the data set, for instance, this is customer demographics, then you are able to assess before you proceed from.
This you do before anything.
Yeah, before anything. Yeah.
So in the case that they need to provide the information they need.
Exactly. Yeah. So for the information they have, they provide. For those that they don't have, as a data scientist, for instance, missing values, you know how to handle them because you will.
They will know how to handle them.
Exactly. But in the report, if you are going to assist them to solve that, you need to indicate in the report, the final report, so that they are aware that yes, our data had missing values, but this is how you are able to handle as an expert, and so on. But before that, it is very important, this one. Then another thing, as we wind up this session, the first session, is that in any data, it is always advisable that you don't interfere with the original data. Like when I send you an Excel data set, create a copy so that you don't interfere with the original. You just start manipulating a copy of it. Because if you interfere with the original one, it becomes, you cannot trace. If you do what you call an audit trail, I don't know, have you ever heard of audit trail? Like you are trying to follow up to see, like where did it start in that procedure? It will be very difficult. So never interfere with original data. Just create a copy before you start doing anything. So I think that one brings us an end to the first session. Yeah, we are not yet done with the introduction, but yes, just the first session of it. I give you 1 hour break. Okay. Then we come back to 1 to exactly 2. We will be done. But now I just want to upload this so that I can share the link, the recording, and the notes also by email and the WhatsApp group that we created. Yeah. Maybe, do you have any question? Okay, I hope you have enjoyed the session. Okay. I think I can stop recording.